Hi guys, I hope your practicing in combinatorics is going great. And let's see then one exercise about permutations with repetitions. In how many possible orders can the letters of the word mathematics be arranged? This is a very basic exercise. It's just the application of the theory. So we have a word with 11 letters and there are three couples of equal letters. So there are two M's, two A's and two T's. If the letters were all different, there would be 11 factorial possible orders. But you know from the theory that when you have groups of letters which are the same, you have to divide by the number of elements in each group. So 11 factorial divided by 2 factorials because there are 2 M's, times 2 factorials because there are 2 A's, and times 2 factorial because there are 2 T's. And that's all. But if we want to revise the reason why this formula is correct, we can think of the fact that if all the letters were different, you would have 11 factorial permutation, and this is clear. Now, let's suppose that the two M's were different. So, for example, you have M1 and M2, let's say, or a red M and a blue M, okay? So you would list all the possible ways to write all the permutations, okay? But when you realize that the two M's are actually the same letter, so you have a blue M and red M, but some rows below you have the blue M here and the red M here, you realize that the two permutations are actually the same permutation. The same fact is for all the permutation that you have read. So you can group all the permutation in groups of 2. You can group them by 2. So you realize that actually you have double counted. You have counted every permutation twice because you have identified as two of them as two different elements when actually they are the same element. The same reasoning can be done for the double A and for the double T. So this is the reason why you divide this way. Now you just have to perform your calculations. So 11 factorial divided by 2 times 2 times 2, which is this number. It is interesting to develop a second method because you can think of the fact that you have to fill in 11 blanks, 11 slots, 11 seats, 11 cells as usual, and think of how many ways there are to put the two M's. So you can put the two M's in the first and in the second cell, or in the first and in the third, in the first and in the fourth, or in the third and in the ninth, etc, etc. How many ways are there to put the two M's? There are 11 binomial 2 ways, because you can see the positions of the two m's as groups of 2 in a big group of 11. So the number of subsets made of 2 elements in a set made of 11 elements. So the number of pairs in a set of 11 elements. Okay? But now that you have placed the two, you have counted the ways of placing the two m's, there are 9 blanks left. So you have to fill in 9 blanks yet. And you have to put the 2 a's. So how many ways to put 2 a's in 9 cells? Exactly 9 binomial 2, exactly for the first, the same reason as previously. And how many ways to put the 2 t's in 7 cells that are left? 7 binomial 2. So now you have placed the 2 m's, the 2 a's and the 2 t's, and you have to fill in 5 blanks with 5 different letters, the 5 different letters which are H, E, I, C, S. So how many ways? Of course 5 factorial. If you develop, you find 11 binomial 2 is 11 times 10 divided by 2. This is 9 times 8 divided by 2, and this is 7 times 6 divided by 2. So now all the factors here, 11 times 10 times 9 times 8, etc., etc., until times 5 factorial is exactly 11 factorial. Divided by 2 times 2 times 2. So you find exactly the same final result. Nothing to spot as new terms, so for our vocabulary corner. So see you soon. Until next time, take care. Bye bye.